sts119 payload manager,
Morning.
and Kathy Winters, the shuttle weather officer.
Good morning.
We'll hear from our panelists, and then we'll take questions. Steve?
Thank you. It's really good to be here finally to give you a launch countdown status and let you know how we're doing on the Space Shuttle Discovery's launch on Wednesday to the International Space Station. Preparations are in work for this Wednesday's launch. We're going to bring astronaut Koichi Wakata, the S6 integrated truss segment, up to the orbiting space station and bring back astronaut Sandy Magnus, who's been up there for a few months now. The flight crew arrived on Sunday, and as you probably know already, they are really excited as we are to be in countdown and getting ready for Wednesday's launch. At this point in the count, things are proceeding smoothly. We're tracking only one minor issue. We're troubleshooting one valve we use for post-launch operations, and we should have that fixed probably by this afternoon. And really, there's not a whole lot else going on in that category. Things are going quite well at the pad. We completed our loading of onboard reactions last night. We've already demated the mid-body umbilical unit that we used to load those reactants on. It's now retracted, and we've closed out the panels on the side of the ship associated with that. You might have noticed on this particular countdown, it's 4 hours longer than your average countdown, and we're doing something a little different. We've done it before, but we're doing a reactant offload on this particular one. We loaded all our reactants last night, and we took off 300 pounds of LOX. And the reason why is because we're getting a lot of our power anymore from the solar panels on space station. And so we don't need to carry quite as much reactant uphill. We're bringing a lot back after the missions. So we took 300 pounds off, and it gives us a little more ascent performance margin. And it makes it safer for us and gives us a little more options on the way uphill. We're looking at somewhere around 1,750 pounds of ascent performance margin at this point. This morning we completed our initial preps for external tank loading. We're working on main engine pneumatic checkouts at this point and the flight crew stowage. We have, throughout the rest of the day, we're configuring the vehicle and pad for flight by removing equipment that we're already done using, closing out the panels on the side of the ship and retracting platforms away from the vehicle. At 3 p.m. this afternoon, we'll begin our T-minus 11-hour hold. And during that hold, we'll be checking out our ground communications network and preparations for checking out the orbiter communication system at 7 p.m. tonight. Retraction of the rotating service structure is scheduled for 1 o'clock in the morning. And with a clear night we're expecting and the full moon and the xenon lights turned on, it ought to be a very beautiful sight out at the pad. Our countdown should resume at 4:55 in the morning at T-minus 11 hours, at which point we'll begin preparations for fuel cell activation. Final crew module configuration and pad closeouts continue after that, and we're looking for preparations for external tank load, which should begin at 11:55. After the completion of the tank load, which is about 3 hours worth, the flight crew should arrive at the pad at approximately 6 p.m. on Wednesday evening. Our launch window is a standard ISS launch window. It's 10 minutes in length, and it opens just after 9:15 p.m. We traditionally wait till the middle of the window, so at about 9:20 is when we expect to launch, plus or minus a few seconds, and we generally adjust to that time at the T-minus 9-minute hold. This is a 14-day mission. We have 1 contingency day if we need it, and 2 weather contingency days if that were to be the case. They have 4 EVAs planned, and once we have all work complete on orbit, we'll leave astronaut Koichi Wakata on station, and bring back Sandy Magnus. Discovery and her crew will come back, hopefully, on Wednesday, March 25th at 3:27 p.m. local. If for some reason we weren't able to go on our first day, we'd have the window would open about 25 to 35 minutes, or 23 to 25 minutes earlier each day. And starting on Thursday, March 12th, we'd had opportunities to go on flight day 3 or flight day 4. We could go through the 16th at the moment is our preliminary few days we're considering if we needed to go that late. The 16th is a flight day 4 only opportunity, but we have some adjustment we can make to try to get a flight day 3 out of that one as well. On March 13th, you've probably heard we come up against something we call the Soyuz cutout. And that is a date set in advance of the launch of the Soyuz capsules so that we can get up on orbit, get to station, complete our mission, and undock before they arrive up on station. If we needed to, we could adjust that cutout date by a couple of days if we were willing to shorten our mission. And there's a EVA taking place right now which would give us some flexibility should we do that. The range is currently clear for the 11th and 12th launch opportunities. There's an Atlas rocket on the range for the 14th. If we went that late, obviously we'd begin discussions with them to see if we could work something out. We have enough onboard reactions to get 4 launch attempts in 5 days, which is our standard going-in plan. We have 10 days of hold time for liquid hydrogen and 11 days for liquid oxygen, and we shouldn't need to top off until after we've made our 6th attempt. So in summary, at this point, we have no real concerns. Our systems are in good shape. The countdown is proceeding on schedule like it should be, and we are ready for the exciting mission that lies ahead of us on Wednesday night. Andrew?
Thank you, Steve. Robbie?
Okay, thank you, Candrea. As Candrea mentioned, I'm Robbie Ashley, NASA's mission manager for the Starboard 6 or S6 truss element. And as I'm sure many of you are aware, S6 will be the final piece of the International Space Station's 11-segment truss structure. S6 was installed in Discovery's payload bay back in January on the 17th, and the payload bay doors were closed for flight on January 21st. And since then, the payload bay has been under a nitrogen purge, keeping the conditions in and around the S6 element at a dry, comfortable 65 plus or minus 5 degrees. A nice, comfortable environment for the S6. We're not tracking any issues with the S6 truss, and it remains ready for launch tomorrow. And when it launches tomorrow, it will be kind of a bittersweet moment for much of the team here at KSC, but not just here, but across the country, who have been part of the S6 story. Although it's the last truss to launch, what you may not be aware of is that it was actually the first truss that was built for station. It began its life as the qualification model for the 4 power modules on station, and as such was the first one built so that it could be put through the extensive qualification testing even before the P6 element was launched to become the first power module put up on station back in 2000. As the qualification model, S6 accumulated the most road miles of all of the truss segments, making starts and stops across the country in places like Tulsa, Oklahoma, Denver, Colorado, Huntsville, Alabama, Houston, Texas, and finally here at the Space Coast. And literally thousands of people have played a hand in getting S6 to where it is today, ready for launch tomorrow out at Pad 39A. The story began years ago with the design of the space station elements, and then on with manufacturing. S6 went through, as I mentioned, an extensive qualification test program. It was then upgraded to flight status, and then brought here to the Space Center for final integration and acceptance testing, closeouts, and certification for flight. And as such, it's been here since 2002, and it's become an old friend for many of us. So we're excited about the impending launch, but at the same time there will be a little sadness, as this will mark the end of an era for the space station program, or at least the folks processing the elements here on the ground. With that, let me move on and talk a little bit about the rest of the payload complement flying on this mission. In the orbiter's middeck, we have about 1,400 pounds of station hardware that will be flying up, and that's a combination of hardware and utilization of research science experiments. The experiments that will be flying on this mission will be taking up the Japanese dome gene experiment, as well as a national lab Pathfinder vaccine development experiment looking at developing vaccines for pathogenic organisms. We have 2 short-duration bioastronautic investigations, one looking at immune monitoring and developing a monitoring protocol for astronauts' immune systems with the intent of trying to develop a minimal impact protocol that fits into the busy flight schedule, as well as an experiment looking, or continuing experiment looking at sleep patterns of astronauts on orbit and trying to improve their quality of sleep, which is important for astronauts as we proceed on to the longer duration spaceflight missions. In addition to these experiments, we've got 2 subrack facilities that we're flying up in the middeck, the Glacier, which is a refrigerator system for keeping experiment samples under cold storage, And the European Space Agency's protein crystallization diagnostic facility will be flying up and will be transferred to the Columbus module for protein crystal growth studies in Columbus. And let's see, I believe that's all I have. We're looking forward to tomorrow, the launch tomorrow evening. I'm sure it will be beautiful, night launch, and getting